Hey guys, hope everyone is doing well. So I figured in order to prepare for the assessment tomorrow, I would just go over that individual preparation sheet that we did during math class today. Okay? If you're able to do this sheet, you're good to go. Also, the key packet that you were given um, last Friday, and some of you are absent, I gave it to you today. If you study this, I mean, you're going to be really good to go, okay? So once again, Johnny Bravo decided to go to the movie theater and buy some popcorn. There were 6 pieces of popped popcorn, in the popcorn maker. Every second after that, the number of popcorn increased by a factor of 4. That's all important. It takes 10 seconds for the popcorn to finish popping. So it kind of seems like this is going to be important for our domain and range. It's not like this popcorn keeps popping for the rest of the time, okay? So for me, I don't like that this table says x and f of x, so I'm going to start labeling things based on what we see. I know on the left hand side they're usually talking about time, or it's the independent variable. It's the thing that we can control. So they're talking about seconds, so sorry, that's white. That should be going there, okay? And what's dependent, what's changing because of that is the number of popcorn. Alright? So hopefully that's okay. By the way, your test already has these labeled. Once again, I'd like to make these reviews harder. Algebra, we like to make these reviews harder than the real thing, so you'll be good to go. Alright, so we always start off with 0 seconds. And I like to go up by 1, personally. At the beginning, aka when it was 0 seconds, I said that there were 6 pieces of popcorn, so it's 6. It increased by a factor of 4, which means times 4, because this word factor is there. So you'd multiply by 4. So 6 times 4 would give you 24. 24 times 4 would give you 96. And if you multiply that times 4, that's 384. Okay? I love that when I was walking around during class today, I saw a lot of you guys keep this table going because you said, you know what? It goes until 10. Right? So keep doing that. Keep going, blah, 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 until you get to the number 10. When you're multiplying it out, should have gotten some crazy huge number. Another way to figure this out, instead of multiplying by 4 the whole time, is to just plug the x value in to your explicit, but I'll get to that later. Give me 1 second. And the number you should have gotten for 10 seconds, if you kept multiplying out, I'll type it because it's a big number. Bam, 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 bam. So let me put my, It's ridiculous. It's absolutely ridiculous. But anyways, the number you should have gotten for this last value would have been 62,914,156. Once again, I just kept multiplying by 4, right? In order to get to here. For the sake of the video, I'm not going to do that, but I know you guys are able to multiply by 4 in a calculator, so I'm not going to go there. Okay? Alright. So, discrete or continuous. Discrete means it is skipping. It's something that's jumping. You can count it, right? Continuous means it can be any fraction, any decimal, right? Like you can stop traveling and you're still going to be somewhere, right? So, in regards to this, you can argue it both ways, to be completely honest, but it's more on the side of being discrete. And I would say this function is discrete because let me model. The number of popcorn jumps. You can't have, and I'll just give out some crazy decimal, right? Like 1 point pieces of popcorn, right? It's jumping in value, okay? Alright, so since I said this is discrete, my domain and range should also be jumping, alright? So I know my first domain, and by the way, don't forget, domain is your x values, right? Range are your y. So my domain would literally start with the first second, which was 0, and I would just keep going until I get to 10, right? Range would be the same thing. You do 6, 24, 96, 384, hold on, let me catch up, 1536, 6144, blah 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 blah. You would keep doing that until you get to your last number, which was that craziness, okay? And maybe space it out. That might be good to do. Alright? Graph. Really, graphing is just graphing it, right? The only thing I would say to remember is that you have to skip by a consistent number. If you want to skip by tens, you have to skip by tens the whole way. If you want to skip by 100, you have to skip by 100 the whole way up, okay? That is just dependent on you. Explicit. This one is where you need to start off with step 0, okay? So if you start off with step 0, the value is 6, because that's what's here. It's at the beginning. And to that 6 each time you're multiplying by 4. And you need an x somewhere, and it should go up here. And the x goes up there because we're multiplying, right? We've learned that, okay? And to be 100% correct, you should say like f of x equals that stuff. Or if you said s of x, s of n, whatever, okay? But that's pretty solid. Recursive. 2 parts are needed for this. 1, you need to tell me what step 0 equals, which in this situation is 6, right? 2, you need this setup, like s of n equals s of n minus 1. I know that looks like an h, but I don't feel like fixing it. And what's happening each time? You're multiplying times 4. So just as a reminder, this will always be in every recursive equation. Step 0 should always be for every recursive equation. The only thing that's changing is what's out there and what's here. Okay? Alright, so that is that. Is the sequence arithmetic or geometric? Well, I would say that it is. I would say the sequence is geometric because there is a common ratio of 4. Don't tell me it's multiplying by 4. Okay? And that's one thing I'll give you a reminder of right before the assessment. You have to tell me, oh, it's arithmetic because there's a common difference. It's geometric because there's a common ratio. Remember I said we're trying to up our level of vocab, okay? Explain the rate of change. I would first set it up. Y over x, right? If you go back to our table, the y's, we already talked about it. Or I talked about it to myself because I'm weird. I'm talking to a computer right now. This y column is multiplying times 4. This x column is adding by 1, right? So you'd put times 4 over plus 1, okay? And just to keep it going, times 4 was for the popcorn, and the bottom would have been the number of seconds that the popcorn was popping, okay? Oh my gosh, this is tough. Alright, so now I am not done. They said explain the rate of change, which we found out. We just did that. In the context of the scenario. Context of the scenario. This is where you have to write a sentence. We have to talk about it in a scenario. What does this 4 over 1 mean? So a sentence that you could have came up with would have been the number of popcorn multiplies by 4 for every 1 second. Right? The number of popcorn multiplies by 4 for every second, for every 1 second. It doesn't matter. As long as you have a variation of that, you're good to go. Alright? Now, let me think about this. Linear is addition or subtraction. Exponential is multiplication. If I go back and I look at my explicit, 1, there's an exponent. So that lets me know it's exponential. I also see that we identified that it was multiplying, right? I'm just making dots everywhere. So, that's another reason why you know it's multiplication. So, if you had to explain this, you would say the function is exponential because you could say you're multiplying, but if you want to be a little more educated, you could say because the sequence, right, aka the numbers, has a common ratio of 4. It's almost the same reasoning as it being geometric, right? It matches up. Okay? So that should be solid. I'm going to do the back. If you're good with the back, stop listening to the video, but I'm going to keep going to make sure we're good to go. Now, for creating your own scenario, you need 2 things. 1, you need to talk about step 0. 2, you need to talk about the rate of change. Okay? So I'll leave that up here. That's kind of your criteria for success for the creating your own scenario. You can make it as long, as fancy as you want. It's up to you. Go wild. But as long as you talk about step 0 and the rate of change, you're good to go. And you'll get 100% on that section if you're talking about the right things. So step 0, they're very nice in this table. They gave it to us. Rate of change. Here, it's not going up too fast, which means it's probably not multiplying, it's adding. And it looks like they're adding by 7 each time. Alright? Here, looks like they're adding by 1. So step 0 is that. And I'm just going to write down here, just as a note, my rate of change is 7 over 1. Okay? Also in your assessment, they're going to give you units here. So let's just pretend they gave you, I don't know, days and butterflies. Alright? So I'm going to make a story. Let me think. So SpongeBob SquarePants went out to chase some butterflies. What are those things called? They're not butterflies. Are they jellyfish? Whatever. Alright. So he's on his way to catch some jellyfish. Alright. At 0 days, or you could say at the beginning, right? Whatever. SpongeBob caught two, or you could say he had two jellyfish, right? Every day after that, like every one day, he caught another 7 jellyfish. Bam, you're done, right? Another story could have been, I don't know, let's pretend it wasn't talking about jellyfish and they talked about the number of miles, right? So, Mr. Hailu is a beast at running. So at the beginning, he ran 2 miles. Every day after that, he was able to run another 7 miles. Right? So that's really the gist of what you need. You need to talk about step 0 once again, right? I talked about at the beginning, at 0 days, 2. That matches it. You need to talk about the rate of change. So, every day, another 7 jellyfish. Every day again, another 7 miles. It's up to you. And like, this next section, your domain and range, if it's discrete or continuous, that depends on you now. That depends on the word problem that you had made, right? Just because I feel like being ridiculous, I'm going to use the SpongeBob example for this problem when I do the rest of this, okay? So just keep that in mind. So, is it discrete or continuous? I would say this is discrete. You know what? I lied. I'm going to take it back. I already did it discrete. Let me do it continuous. I'm going to do the miles. Alright? Once again, this could be argued both ways. It's closer to continuous. But honestly, if you have a good backing, you know, if you feel like, whatever. Anyways, I'll just keep going. I'm talking a lot. This is continuous because, remember, discrete is jumping. Continuous means you can have any decimal, any fraction of it. So continuous because, you know, in between the days, Mr. Hailu was able to run some numbers between 2 and 9, right? Like, I don't all of a sudden become able to run an extra 7 miles, right? Like, if I'm dedicating my whole life to a marathon and I'm training, I'm probably going to be able to run like 2.5 miles. And then eventually, you know, by noon, when it's time for like my grilled cheese sandwich and tea, I'm able to run 4 miles. After another few hours, when I'm eating a PB&J sandwich in the evening, I'm able to run 7 miles. And then after that, I got tired, I took a break, and I was able to run 7. Like, distance, the number of miles is continuous, okay? You can make a case for it being discrete, but I'm going to stick with continuous with this just because I want to go through it with that. Domain and range. When it's continuous, you need this setup. Okay? Alright, you should put a number there. And I never told you how long I was going to train. Right? So, to be honest, I would never stop training, according to this word problem. I know realistically that's not true, because eventually I will not be able to run an extra 7 miles every day. But according to this problem, it goes from 0 to infinity, right? Alright, Now the first y value over here is 2. And that also goes up to infinity. Because if we don't know what the last x value is, we can't calculate this last y value. Okay? So it's infinity. Keeps going. Explicit. You need to start off with step 0, which is 2. And each week we are adding by 7. And your x goes down here. It's on the same line. Cough, cough. That's why it's linear. Alright. So recursive. You need to start off with step 0. Step 0 equals 2. Got this recursive equation, right? Ba-bam, 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 bam, bam, bam. And you're adding by 7 each time. Graphing it, if it looks like that, you graphed it wrong. Okay? Is the sequence arithmetic or geometric? What do you guys think? Exactly! I just pulled a move from like Dora the Explorer. You know, like they're talking to you even though they can't hear you in the TV shows. It's kind of weird. Alright. This is an arithmetic sequence because it's adding. No, don't say that! Be more educated. There is a common, good job, difference of 7. That's it. Explain the rate of change. We already talked about it. This is going up by 7. And I know you could look at that and tell me it's going up by 1. So I'd start off by writing 7 over 1. Right? What's going up by 7? I said miles. And I believe this was days. So make that match. Miles. Days. And just like the last problem, explaining the context of the scenario. Bam, bam. Alright. Mr. Hailu runs another 7 miles each day. That's it. That is me explaining this rate of change. And if you want to say each one day, you can say that too. Up to you. Is it linear or exponential? You see how this x is on the same line? That makes it linear. That's one way to remember it. Another way, like we said before, linear is for addition or subtraction. Exponential is for multiplication. Okay? So, this function is linear because, same thing, a common difference of 7. Okay? Alright, so that's it. For real, for real. I wish you guys the best. Hopefully this video helps those of you that watch it. For those of you that don't watch it, it probably won't help you because you didn't watch it. Anyways, if you watched the video on your way into class, smile at me and give me a high five. Alright. I appreciate your hard work and have a good night, guys. Bye.